Hi dear, last class we have seen this reaction of bases with metal, non-metal oxides, and then reaction with the bases. Reaction with the water, right? So we have seen that when the bases react with water, it ionizes to form OH minus ions, right? OH minus ions. So do all the bases will dissolve in water means no, because the classification of bases itself is soluble in water and soluble bases and insoluble bases. Okay, so based on that, all the bases do not dissolve in water. Okay, we can say some of the bases which dissolve in water are called alkalis. Okay, an alkali is a base that dissolves in water, or we can say that bases soluble in water are called alkalis. Okay, so some of the examples of alkalis are NaOH, potassium hydroxide, calcium hydroxide, and sodium hydroxide. Some of these are okay. So what will be the nature of this things means they are very soapy to touch, bitter in taste, and corrosive in nature. It is highly corrosive. Okay. So we usually use this in the uh, drain unblocker. It will be used as a drain unblocker. Okay, because it is highly corrosive in nature. Okay, if any blocks are in the drain, it will clear easily. Okay, that's why it is used as a drain unblocker. Okay, so those things which are those base which are soluble in waters are called alkalis. You will see water alkalis in higher classes in detail. Why it is dissolved in water. Okay, soluble in water. Okay, next, one more important thing we must know is in our day-to-day life we must know this. Okay, acid or a base in water solution. Okay, so which has to be put in which, acid in water or water in acid. So if you add acid or base to water, you know that when it is reacted with water, it ionizes to form H plus ions and OH minus ions, right? So which has to be added means this, for example, if HCl, okay, when added with water, okay, so what it will do, it will break the bond between the H and Cl, right? So it ionizes to form H plus and Cl minus ion, right? So it's breaking the bond. Once the breaks bond, a lot of energy will be released. So a lot of energy is released means that is a exothermic process, right? Exothermic process. Okay, so lot of energy will be released. So always, this is water, take this as water, and you have to pour the acid drop by drop or slowly. Okay, you have to continuously stir and then put drop by drop. Okay, so when you put drop by drop, only few molecules will combine here, and only few HCl will break down into H plus and Cl minus ion. So only less energy will be released. Okay, in case this is a correct way to add acid in water. Okay, if you add, this is your acid, and if you pour water here, okay, if you pour even a little bit of water, it reacts with highly concentrated dense hydrochloric acid, any acid. Here the water will react with more number of HCl. For example, 50 numbers of HCl molecule is there means, if you pour water, all the HCl molecule will ionizes. Everyone will all the HCl will be ionized, H plus and Cl minus, H plus and Cl minus. For breaking of all this bond, so much of energy will be released at a time. So when it is released at a time, so splashing of the acid will happen. Even breaking of the beaker may also happen. Okay, because the water reacts with all the HCl, So all the HCl at a time it will ionizes to form the H plus and Cl minus ion. While breaking the bond, will get a lot of heat energy. Okay, that will splashes out, and even you can it can break the beakers. Okay, so this is the wrong one. It should not be followed. Water should not be added in acid. Okay, only acid should be added slowly to the water. Okay, this is very important thing. Okay, so the process of dissolving an acid or base in a water is highly exothermic. Exothermic means what? Lot of heat will be released. Okay, acid must always be added slowly to the water with constant stirring. Okay, we have to slowly add the acid. Must always be added slowly to water. Okay, acid must be always added, not water to be added. Okay, acid must be always added slowly to the water with constant stirring. Okay, if suppose if water is added, if water is added to a concentrated acid, the heat generated may cause the mixture to splash out and cause burns. Even the glass container may also break due to the excessive local heating. Okay, clear on this? So water should not be added to the concentrated acid. Acid should be added to the water slowly. Okay, and one more reason, if you see, means this is also the one of the main thing. And when compared to the acid, water is low in density, right? So it will be above the acid. So all the reactions takes place in the surface of the water. Okay, surface of this acid. So here itself all the reaction taking place and splashing of the acid will happen. Okay, when you pour acid to the water, its density is high, it will comes down and your reactions will happen here. Only few molecules are ionized and only less energy will be, heat energy will be released. Okay, so this is the safer method, adding acid to the water. Okay, mixing an acid or base with water results in decrease of concentration of ions, that is per unit volume. Such a process is called dilution. Okay, dilution means mixing of acid or water with the water. Okay, so here the H plus and this, that H plus ion will not exist independently, will not float independently. So it immediately mixed with water to form hydronium ions, H3O plus H3O plus ions. Okay, so mixing, what is meant by dilution? Mixing of an acid or base with water per unit volume, that increases the concentration of ions per unit volume. Such process is called dilution. Okay, then we'll move on to the indicators. So what is indicators? That it shows the presence of whether it is an acid or a base, right? So by how it indicates it? By changing the color, it will show us that whether it is an acid or a base. Okay, see indicators. It is a chemical substance which gives different colors in acidic and basic solution. Okay, it will give changing of the color indicates that it is whether it is acid or a basic. Okay, there are mainly two types of indicators are there: natural indicators and synthetic indicators. Okay, natural indicators available in nature reserve. Synthetic indicators will prepare in the lab. Okay, natural indicators, very well know about this. Litmus solution and turmeric is the natural indicator available in that. Okay, synthetic indicators, we in lab they prepare methyl orange and phenolphthalein. Methyl orange and phenolphthalein. Okay, we'll see in detail slightly. Natural indicator. Litmus solution is a famous indicator. Okay, usually it is the natural indicator. So what is the actual color of this litmus solution is purple dye. Okay, purple in color. It is neither acid nor basic. Okay, from where we got this litmus solution? It is extracted from the lichen plant. Okay, it belongs to a Talophyta division, plant kingdom. Okay, in the division of thallophyta, you will have lichen. From that you will extract the solution that is purple in color. Okay, it is neither acidic or basic. Okay, so it is used as a acid base indicator. For both the things we can use. Okay, it can be used as a acid base indicator. You know that this purple dye is in the lab they use this purple dye and make this litmus paper, right? Acid means what? Acid means it turns the blue litmus paper into red, right? In the blue litmus they in the lab they kept as a blue litmus solution or blue litmus paper. Okay, so when you dip in the acid, it color changes to red. In case of base, they are prepared a red litmus paper solution or paper that will be converted into blue color. Sorry, blue. Okay, blue color. This we already studied, right? Acid means it changes the blue litmus solution to red litmus. Base means red litmus solution to blue litmus. Okay, it is available in lab as blue or red litmus solution, and also the paper, blue litmus paper or red litmus paper. Okay, then turmeric. Turmeric it turns when base is added. When base is added, it turns into a reddish brown color. If any turmeric are spilled in your dress, means if you wash with the soap, immediately when you apply the soap, that yellow color will be changed into reddish brown. If you have noticed that, you can remember that this reddish brown color. Once you wash the soap, then it comes to either it will be removed or you can get the yellow color again. Okay, so when the base is added, the turmeric yellow color will be converted into a reddish brown color. Okay, when the acid is added, there is no change, that will be in yellow color only. Okay, some of the other indicators are red cabbage leaves. Red cabbage means you have seen that purple color, right? That is usually called as red cabbage. Okay, that extract also they are using for used as an acid base indicator. Okay, and the colored petals of flowers such as hydrangea, petunia, geranium, and one more is hibiscus also. We'll use this petals of the flowers as a indicator, acid base indicators. Okay, these are the natural indicators available. Okay, we'll move to the synthetic indicators. Synthetic indicators is also a acid base indicators. Okay, in the lab we are using the methyl orange and phenolphthalein as a acid base indicator. Okay, what is the color of the methyl orange solution? Is orange in color. Okay, methyl orange color is orange in color. When you put the drop of methyl orange in the acid, it turns to red color. Okay, when the methyl orange is turned to red color, then indicates the presence of acid. Okay, when the methyl orange is turned to golden yellow color, then it shows that it is the presence of base. Okay, in the presence of base, it turns to golden yellow. In the presence of acid, it turns to red color. Phenolphthalein is colorless. Okay, phenolphthalein is a colorless indicator. Okay, when acid is poured, there is no change, it remains colorless only. Okay, it remains colorless only. If you put base, it turns to pink color, bright pink color. Okay, dark pink color we can see. Okay, this is the synthetic indicators used in the laboratory. Okay, next one more special indicator is there, olfactory indicators. Okay, olfactory indicators. So it does not shows the presence of acid and base by change in color, but based on the change of order. Okay, the substance whose order changes in acidic and basic media is called olfactory indicators. Okay, the substance whose order changes in acidic and basic media is called olfactory indicators. We'll see some of these olfactory indicators in detail in the activities. Okay, so many activities are there in the book. We'll see in the next class. Thank you.